end of trigonometry. So the first thing we're going to look at, we're going to be solving right triangles. Now, what we saw last time, oh, excuse me, is we were introduced to sine, cosine, and tangent. So if we have a triangle, now let's remember what a right triangle is. A right triangle has this 90-degree angle in it, this perfectly vertical part. Or if it could be tipped over, you could have a right triangle got knocked over, but it still has that 90-degree angle. Excuse me, it's like the corner of a very uncomfortable chair. And we'll choose an angle. Let's say we have an angle A. The little arc there to indicate an angle. Now, the side across from the 90-degree angle is the hypotenuse. The side opposite the angle we're interested in, well, that's called the opposite. And the side next to the angle we're interested in, that's not the hypotenuse, that's the adjacent. And what we saw last time was this. The sine of our angle is the opposite over the hypotenuse. The cosine of our angle is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. And the way we could remember this, there's a little mnemonic. It's SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And what's important about these, and this is a way of thinking about it, your calculator has the sines and cosines of pretty much any angle you can come up with. And we're going to use that to solve a right triangle. What solving a triangle means is we're going to find all the missing angles and all the missing sides. So we know all the angles and all the sides. Now, there's a fact with triangles I need to mention. The sum of all angles in a triangle is 180 degrees. The sum of all angles in a triangle is 180 degrees. A little example here. So for example, let's say we want to solve for angle A. Solve for angle A. Well, one thing we want to do, we want to identify this 90-degree angle. So this right here is 90 degrees. So what we have is 60 degrees plus 90 degrees plus A. Well, according to this rule, those will equal 180 degrees. The sum of all the angles in a triangle is 180 degrees. So let's add the 60 and 90. They're like terms. They're constant terms. That's 150 degrees plus A is 180 degrees. Now I want to get A by itself. So I want to cancel the 150. We have a positive 150. We cancel it with a negative 150 or subtracting 150. And we better do that to both sides because we have an equal sign. But we do the one side, we do to the other. And so we're going to get A is 30 degrees. Questions about that? All right. So, excuse me. Now, when we're going to solve for the sides of a triangle, I need some calculator help on this. Now, for now, we're going to limit ourselves to right triangles. That means they have to have that 90-degree angle in there. And the thing with that, we're going to talk about triangles that don't have a 90-degree angle at the end of tonight. There's two approaches to those generally. So let's say we need to solve the triangle. So where do we start? Well, what are we missing here? Well, on the sides, let's call this A. Let's call this side B. And this angle here, let's call this X. So we're missing three things. We're missing this side, and this angle X. Well, angle X we can find. So remember, the sum of the angles has to equal 180 degrees. So 38, 90, X, those have to add up to 180 degrees. So if we add our 38 and 90, we'll get 128 degrees plus X is 180. Get X by itself, subtract 128 from both sides. And that's going to give us 62. Oh, I'm sorry. 52. So that's how we can find angle X. So now we've got that figured out. What do we do about A and B? Well, we have done a little work with the sides of a triangle, solving for an X when we use the Pythagorean theorem. But we would need to know one of these, because if we tried to do Pythagorean theorem now, if a squared plus b squared would be 14 squared. Again, the hypotenuse here is always on the end of the Pythagorean theorem. But we've got two unknowns instead of one. So we can't solve and get a number for a or b. So what can we do? We're going to use some of those trig functions. Let's solve for b. Now, b, if we focus on the 38 degrees, b over the hypotenuse 14, that's going to equal the sine of 38. So b is the opposite of 38. 14 is always going to be the hypothesis. Hypotenuse, I'm sorry, not hypothesis, hypotenuse. So we want to solve for b, and we can do that. Multiply both sides by 14. If we're dividing b by 14, the opposite of dividing is multiplying. So we get 14 times the sine of 38 degrees equals b. So how do we calculate the sine of 38? Well, this is where you get your calculator. So you make sure you're in degree mode. So sine 38 degrees times 14. And so we get this long number. We get 8.619260655 is equal to b. Now let me check something. I want to make sure. My recommendation on this is to use as many decimal spots as you can and only round off at the very end. So let me just check to see if they agree with me. I just want to make sure the text is agreeing with me on that. Look at their procedure. And so they're actually rounding in the middle of their, let me see, pardon me just a moment. I just want to, because this, I don't want you to enter in correct answers and have them marked wrong. And let's see, they're not saying. So what I'm going to say is this. I'm going to say use as many decimal places as you can and then round off at the end. I'll say that. And if you get marked wrong and you think you've done it right, let me know. I can take a look at the homework assignment, and if it's a round off issue, I can give you credit for that. So if we have b, we still need to find a. So for that, now we can use our Pythagorean theorem. Now let's see. Answer squared is going to be 74.29165423. And then 14 squared. Oh, I'm sorry, why did I put b there? It's 14 squared. 196. And then we're going to subtract 74.29165423 from both sides. Or a squared is equal to 121.7083458. So now we need to square root. So the way we get rid of a square is we square root. The square root and the square act as inverses. They cancel each other out. What we do to one side, again, we have to do to the other. So we get a equals, so my calculator, I'll square root my previous answer, 11.0321555. So now I'm going to round my answers. I'm going to round to the nearest hundredth. So my A is about 11.03, and my B is about, let's see, B was back here. There's B, go to the hundredth, 8.62. So now when we go back to our triangle, we can fill in for side A, and we can fill in for side B. So when we do that, and if I'm going fast, let me know. So side A was about 11.03, and then side B was about 8.62. And there's our triangle. Questions about that? Now, sometimes what they're going to do, they're not going to give you too much information. So they might say something like this. They'll give you an angle. I'll give you a side. Say side is 36 feet. And there's an angle B that's 68 degrees. Now, the way this is set up is they're actually going to use capital letters for their angles. So you would have lowercase letters for your sides. And then your angles are going to be capitals. Squeeze a capital A in there, capital B, and there's a C. And the idea is that the angle, capital B, is opposite the side B. The angle A, capital A, is opposite the side little a. Then the angle capital C is opposite the side little c. And so we know what A is going to be. We know what A is. It's going to be 36. We know B is 68 degrees. We have a C, a B, then we have an A. So first off, we want to find angle A. And we're going to use that rule that says the sum of the angles is 180 degrees. So A plus 68 degrees plus 90 degrees is 180 degrees. And if we add 68 and 90, we'll get A plus 158 degrees equals 180 degrees. Subtract 158 from both sides. We'll get A is 22 degrees. So we've got a solution here, 22 degrees. Now I need to find the other sides, B and C. And we don't have to just use sine. We can use other trig functions. So let's take a look here. Let's say we base our calculation using the 68. Well, B is opposite, and we have an adjacent of 36. So when you have an opposite and adjacent, you can use a tangent. So we can say the tangent of 68 degrees is the opposite side B divided by the adjacent side 36. Now to solve for B, since we're dividing by 36, we need to multiply by 36 to cancel it. So we're going to get 36 times the tangent of 68 degrees is equal to B. Comma there. We do the calculation. So 36 times the tangent of 68. Make sure you're in a degree mode. And we're going to get 89.10312.672 equals B. And then I'm going to round this later. So now we have B. We need C, and to do that, we can use the Pythagorean theorem. Now, C is a hypotenuse. That means this squared plus this squared equals that squared. So 36 squared plus what we got for B with these trig functions. You'll sometimes get these long decimal numbers. That's equal to C squared. So calculate the square of this. I'll take my answer, square it. Ooh, that's a big one. 7939.367.192 equals C squared. And 36 squared, 1296. I'm going to add these two together, 7939.367192, and that's going to come out to 9235.3 367,192 equals c squared. So the last thing we need to do is square root it, because the square root, the square will cancel, but we do to one side, we've got to do to the other. We have 96,1008,1785 is equal to C. So we can round this B and C, going to the hundredths place. 96. And if these are measure numbers, maybe we need to keep the 0 there. And if we look at B here, it's going to be again 89.10. But we're rounding these, so I'm just going to say 96.1, 89.1. And this will be 96.1. So those are going to be our answers. We've finally gotten all the angles and all the sides of that triangle. So, okay, what's the thing with these triangles? Why even mess with this sort of thing? Well, what trigonometry lets you do, it lets you come up for measurements that you can't actually reach physically. So let's say you have this. Let's put in a river. And let's say there's some kind of a post, an old bridge pylon on the side of this river. And you're standing here on the very edge. And you marked a spot directly across from that post. And the distance here is 100 feet. And you use a fairly precise measuring device. And you find out that the angle here is 40 degrees. So what you have is a triangle. And what you're looking for is the width of the river. We're going to call that W. So how do you get the width of the river? If you take a side of the bank you know how to measure and an angle that you know how to measure while sitting right here. Well, what we have is the missing side is opposite the 40 degrees. The known side is adjacent to the 40 degrees. So this forms a tangent. The tangent of 40 degrees is the opposite over the adjacent. So to find the width of this river, we're going to solve for W. And again, we're going to multiply both sides, in this case by 100. So we get 100 times the tangent, 40 degrees, equals W. And if we put that into our calculator, and rounding to the nearest hundredth, you're not going to actually solve the entire triangle. we're going to get 83.91 feet is the width. Excuse me. So the power of trigonometry, it lets us make this measurement or get some idea of what this distance is without actually measuring it. So if you got this rushing river here, you can do that, which is kind of a nice thing. Any questions about that? All right. So the last section that we're going to look at, we're getting into oblique triangles. And the key thing with these are triangles with no 90-degree angle. No 90-degree angle. So how do we do this? Well, there's 4 different situations we're going to look at. And 2 of them are going to be solved using the law of sines, and 2 are going to be solved using the law of cosines. So first, the law of sines. We use this in 2 situations. 2 angles and a side are known. Excuse me. And then 2 sides, as opposed to 2 angles, 2 sides and an opposite angle are known. So this might look like there's side A, side B, and an angle opposite one of these sides, like something like this. Or we could have same triangle. We could have A, we could have B, and then an angle opposite B. That's no. So that would be for this one. For this, we could have a situation where any 2 sides are known, say A or B, and an angle C. That could be known. Or the known angle could be this, or the known angle could be here, but we have 2 sides and some angle. But this angle, this might not be known. This could be the known angle, or this could be the known angle. So let's take a look at some examples. And got to be careful with this one. There is a type of problem where there isn't a solution. So we'll try to look at that too. So let's say we have this. We have an angle, capital A, 47 degrees. And angle B, 38 degrees, and the side A of 8 inches. So let's kind of draw a rough picture of what this looks like. And our picture might not be totally accurate, but we could say angle A here is, oh, let me get a little bigger picture. Here's angle A, which is going to be 47. Angle B is 38. We'll squeeze that in there. Opposite of angle A, 8 inches. Okay, I'm going to draw this bigger. This is 8 inches. Side A, angle A. This will be 38 degrees. We're missing side B, side C, and angle C. So how do we solve this? And you might say, well, can't we do the same thing we did before? And we can't. That's only for right triangles. This is going to be an oblique. So what we're going to do is the law of sines. And the law of sines is this. Sine A over A sine B over B sine C over C. That's the law of sines. So what we really have are 3 different equations we can use. We could set this equal to that. We could set this fraction equal to this fraction, or this fraction equal to that fraction. So we use the fraction that's going to help us. So let's take a look at these b's here. We know the angle B, and we're missing the side B. We know the angle A, and we're missing the side. Oh, and we know the side A. So we want to come up with an equation that has one unknown. So we know A, we know A, we know B, we don't know that. So we're going to use the sine A and sine B fractions. Sine of 47 degrees over the 8 inches equals the sine of 38 degrees over the unknown B. And what we can do here we can cross multiply. So when we cross multiply, we'll get sine 47 degrees times B equals 8 times the sine 38 degrees. Now, the sine of 38 and the sine of 47, they're just numbers. They're going to be some long decimal numbers, but they're just numbers. It's sort of a fancy way of expressing it. We still want to get b by itself. It's being multiplied to this number. So to cancel it, we're going to divide by that number. This entire thing symbolizes a number. And we're going to divide the entire side by the sine of 47 degrees. So what does this look like? Well, we're going to get b equals 8 times the sine of 38 degrees over the sine 47 degrees. And then we can calculate this in the calculator. And what we're going to get, I'm going to round my answer here. I'm going to take 8. Here, I put some parentheses. Parentheses never hurt. 8 times sine 38, close, close, divided by the sine 47, close. And so rounding to the 100th, b is going to be 6.73. And since this was inches, that's going to be b. So 6.73 inches. Let's go back here. We got 6.73 inches. Well, now we need to deal with C. We not only have to deal with side C, we've got angle C. Well, the one thing that does carry over from right triangles is that rule of 180 degrees. Now that does carry over. So 47 degrees plus 38 degrees plus C is 180 degrees. Oh, 47 plus 38, 85. Equals 180. Subtract 85 from both sides. C is 95 degrees. And this is that big angle C. There we go. And granted, this does not look like a 95-degree angle. It doesn't, but again, we didn't see this coming. So, as they say, it's not lifelike. So now we're going to look for side C. And we could use, we look at our law of sines. We could use, we could take the C's fraction and equate it to the B's or to the A's. The common practice is to equate it with the A's only in the sense, in this problem, because with the B's we have this rounded length, and that might not always be acceptable, possibly. So I would use the given values to solve if you can. At least that seems to be the approach they're using in the text. So sine A, again, A is 47 degrees, and we have that exact measurement that they gave us of 8 inches. While if we use the B, that was rounded. And then sine C, well, we know what capital C is, that's 95. And then the unknown is little c. So we cross multiply. And so what we're going to get is sine 47 degrees times c. And I put this in parentheses so I don't confuse 47 times c with sine 47 times c. This is 8 times the sine 95 degrees. And again, what we're going to do, divide both sides by sine of 47 degrees. And we'll get c is 8 times sine of 95 degrees over the sine 47 degrees. And we calculate that. I'm going to put my parenthesis here. So that's all one piece divided by sine 47. And it's about 10.9. So now we've got our triangle solved. So that's how we can use the law of sines to solve this triangle. Now, again, it's in these two cases where we're given two angles and some side, or if we're given two sides and there's an angle opposite one of those sides. Now, I want to show you a situation that can come up. Any questions about this? So sometimes they'll give you a problem that doesn't work. So in that last example, we were giving two angles and a side. And we had to find the two sides and the one angle, the missing angle. Now, let's say we have an angle that's opposite one of the sides. So angle A is opposite side A. And we're given a second side. So if we try to draw this triangle, and again, we actually don't know what this looks like. Let me make it a little bigger. Under 9 degrees, this is 14.8 inches. Let's say this is angle B, this will be side B of 19.5 inches. There's side C and angle C. So this is angle A, side A, which is opposite, and then we have some second side here. So we can still use the law of sines. Now this is kind of a tricky one. First off, I have no idea if the triangle looks like this, and I'm assuming this is going to work, that we actually have a viable triangle, that someone didn't accidentally give me bad information. So This assumption might not be correct, and we're going to find out it isn't. Now, in this case, we're missing two angles. So what do we do here? Well, let's try to find angle B. So we can use sine A over A because we know angle A and side B, I'm sorry, side A, and we're looking for angle B, and we have side B, 19.5, and I'll fill those in. So we're going to get the sine of 109 over 14.8 equals the sine. And now the unknown is inside this trig function, 19.5. So again, what we're going to do, we're going to cross multiply. So you get this times this. I'm being a little more careful with my cross multiplication. This times that. And what we'll get sine 109 degrees times 19.5 equals 14.8 times the sine of B. So what do we do here? Well, we want to get B by itself, but we can't just do it in one step. We have the sine of B. So what we're going to do, we're going to cancel this and then cancel the sine. So we're going to go backwards. Instead of sine B, then multiply by 14.8, we're going to cancel 14.8 and then cancel the sine. So let's divide both sides by 14.8. And we're dividing the sides, entire sides. Get sine, ooh, let me scoot that up, 109 degrees times 19.5 over 14.8 equals the sine of B. And I'm going to turn this into a number. Let's do that. So you have sine 109 times 19.5 divided by 14.8. Get this long number. We're going to get 1.245784610 equals sine of B. Getting close. Almost got B excavated out of there. To cancel sine, we're going to take the inverse sine. And what we do to one side, we have to do to the other. So we got to bring out those inverse formulas. So we'll take the sine inverse of 1.245784610, which will be equal to the sine inverse of the sine of B. So over here, those will cancel out. So let's take the sine inverse. See, my answer was that. So I go shift sine to get sine inverse, put in my answer. Oh, shoot. It's an error. Well, what this means, usually this works, but sometimes they're going to give you a bogus triangle where it doesn't work. So that is a possibility. It's kind of a trick they like to do in trigonometry. So just something to keep in mind. So the last thing to talk about tonight is the law of cosines. We'll give the formulas. There's 3 of them, depending on which one you need. And we'll do an example, and that should be it. Now, you use this case when you have 2 sides and with law of sines, we had an opposite angle. With this one, we have 2 sides and included. This is a special term, an included angle. So to give you an idea of what that's going to be, it's a triangle where you would have angle A, so side A, side B, and you have angle C in the middle. And let me double check something. That sounds like something from the law of sines. Just want to double check that. So I just want to make sure I didn't accidentally put the wrong thing. For law of sines, you would deal with triangles where you had 2 angles, like A and B. And then you could have a side over here, over here, over here. I think I might have mixed up my angles and sides. I apologize. But with law of sines, you have 2 angles and you can have a side, or a side. So we could have something like side C. And then the other side, the other situation for law of sines, so I want to make sure this is correct. We could have 2 sides. So we can have A, and we can have B, and then we need one of the opposite angles. So you'd have an angle that's opposite one of the sides. So let me say we have 2 sides, and then let's say put a C here. Let me double check. 2 angles and a side, or no? I mean, that would be same as law of cosines. No. I take that wrong. That's not. That's not. So you could have this situation: angle, angle, side. This is law of sines. Angle, side, side. But you have to have a side and an angle across from each other. So this would be these 2 here. Would be law of sines. And now we're going to be looking at law of cosines. So law of sines are these 2 situations. And this could move around. This one could be here, and this one could be here. But now we're talking about something else. We have this situation, we have a side, and the angle needs to be between them. That means included. And then the second situation, we have all three sides, but no angles. Questions about that? So there's three equations for the law of cosines, or three formulas, and you use them as you need them. So the first one, side a squared is side b squared plus side c squared. Well, that seems kind of familiar, but we got to do a subtraction. 2 times side b times side c times the cosine of angle A. So it looks like the Pythagorean theorem. You just have to do the subtraction here. And notice the little a and the big A. I'm going to see a pattern here. So it looks like the Pythagorean theorem. And we subtract 2AC times the cosine of angle B. And then the third formula, and again, if it's going to be helpful to you, a squared plus b squared, again, looks fairly familiar, minus 2ab times the cosine of c. And then we're talking about a triangle. It's going to look something like this. There's A, there's B, there's C, B, C, and A. Now, the thing with the law of cosines is that oftentimes you'll use the law of sines to help you out. So I'm going to do an example, and then that's going to be it. And you don't use all three formulas on one problem. Not necessarily. So let's say we have this. A is 106. B, 135. And C is 165. So again, I'm going to do kind of a rough drawing here, kind of get a sense of what's going on. So A is the shortest side, so I'll call this A. So that side A opposite needs to be angle A. And then let's see, the next longest is side B, that's going to be this side. So opposite side B will be angle B. And there we go, longest side is side C. Opposite will be angle C. So let's find angle C first. We have the sides in this case. We need to find the angles. So let's find angle C first. Now, angle C shows up in this formula. C squared is A squared plus B squared. Again, it looks like the Pythagorean formula, but got to do some subtraction. The cosine, side C, angle C. So this will be 165 squared equals 106 squared plus 135 squared minus 2 times 106, 135, cosine of angle C. So 165 squared, 27,225 equals 106 squared, 11,236 plus 135 squared. That's going to be 18,225 minus, let's go 2 times 106 times 135. 28,620 times the cosine of C. So this is going to be attached to cosine C. We can add these two. And so we'll get 27,225 equals 29,461 minus 28,620, and it's still going to be attached to that cosine of C. We're going to have to deal with that later. We're going to solve for cosine C. So usually what we would do is we would calculate the cosine, then multiply, and then do the subtraction from that number. I'm going to go backwards. We're going to cancel this number here, then cancel this, then cancel that. So a positive number here. So we're going to subtract 29,461 from both sides. Do that on the calculator. We'll get negative 2,236 equals now a negative 28,620 times the cosine of C. So now we need to divide. So we got to divide by negative 2,8,620 because it has a minus sign on it. It's going to be minus here, but we're actually canceling this. So we're dividing minus 2,8,620. And so we're going to get this number 0.078 127 184 equals the cosine of C. So now we need to take the cosine inverse of each side. And so we're going to get C on the right side. So we need to, here's my answer. So shift cosine inverse, the answer. And we're going to get about 85, and I'm going to round. I'll round 85.2. Probably shouldn't round, but the textbook is actually rounding. So I'm going to say 85.2 degrees is going to be C. So that's one of the angles. And we got to find the two others. Now the good news is we don't have to use the law of cosines. That's obvious, you've seen. It's pretty intricate formula. So we found angle C. That's 85.2 degrees. Squeeze that in there. Now what we're going to do is we can actually use the law of sines. So we know angle A, we know side A. So we know angle A, we know side A, and then let's solve for, let's see, we can solve for, oh wait, I'm sorry, C. Ooh, my bad. This was angle C. So we know angle C, side C. So we need to use this. Angle C, side C. That's what we figured out. Now let's look for angle A. And we'll just use the law of sines there. So the important part with these questions with law of cosines, we're now going to use law of sines. So sine of 85.2, and again, the book's allowing us to use these rounded numbers. Well, we don't know sine A. We do know the side. The side's 106. And so I'm ready to go about maybe 5 more minutes and we should be done. Apologize for going over time. So again, we're going to cross multiply. We'll get 106. Okay, sorry about that. Whew. A little worried. So 106 times the sine, 85.2 degrees equals 165 times the sine of angle A. We got to do the same thing. We're going to get to this, but we have to cancel this and then cancel that, and then we get to that. So cancel multiplication by 165, we divide by 165, and we're dividing both sides. So we get 106 times sine of 85.2 degrees over 165. That's the sine of A. Oh, sorry, I pull that down. That's what we get when we divide. So 106 times sine 85.2. Put in my parentheses, make sure this is a full unit. Divide that whole top part by 165. Now we still want to use the full number here. We're going to round when we get the number at the end, the angle at the end. So to cancel the sine, we use the sine inverse. So that means the sines will cancel. And then if I calculate sine inverse my answer, which is that, you get rounding to, looks like about 39.8 degrees. So that means A, about 39.8 degrees equals A. So going back to the triangle, we now know this. 39, squeeze it in there, 39.8 degrees. How to find angle B? Well, what we're going to do, we're not going to use law of sines. We're not going to use law of cosines. We're just going to use that little fact that the sum of the angles has to be 180 degrees. So 39.8 degrees plus 85.2 degrees plus B is equal to 180 degrees. 39.8 plus 85.2, 125 degrees plus B equals 180 degrees. Subtract 125, and we finally get B is 55 degrees. Squeeze that in there. Triangle's way too small. And so that's how we could use the law of cosines. And you notice that we use the law of sines along the way. Draw a bigger triangle. The thing with law of cosines, in this example, we only searched for angles. Now, sometimes you might solve for a missing side. That does come up. So just letting you know. But that's gonna be it. Any questions about that? All right, well, I promised that'd be the last example. Unless you want me to do another one, I'll stick to that. If you want to look at one where they're looking for a side, look at example 6 in the text, and it's page 712. And it shows them looking for a side. But other than that, that's going to be it. If you have any questions, let me know. Other than that, have a wonderful evening.